Hi, everyone. Good afternoon or good morning, depending on where you're tuning in from. Welcome to our first virtual road trip of 2023. I'm Molly Berry with ATS, and it's my pleasure to welcome you on board today. We're joined by Steve McReynolds of Duval Asphalt and Richard Stager of Ingevity. And they're going to discuss a case study completed last year at one of Duval Asphalt's plants using warm mix at 4 different temperatures. So historically, warm mix studies have been focused on the effects of binder, mix performance, and pavement design. But this study compares the difference in visual emissions and fuel consumption when producing with warm mix at lower temperatures versus normal production temperatures. So Richard will start the trip going over an outline of what's going on in the sustainability world with all of our favorite acronyms like EPDs, LCAs, GWP, etc. And he's also going to review Duval Asphalt's EPD created for the mix in this case study. Steve's going to provide a contractor's perspective of working with the warm mix regarding production and paving, and he's going to review how it performed at the different temperatures. So just a reminder, it's been a little bit since we've had a trip. You're all in listen only mode. If you'd like, you can join the conversation later audibly. Just raise your hand and time permitting, we'll unmute you, and you can address our panelists audibly. So you can also type your questions or comments in the Q&A box at any time. Today's co-pilots are Richard Stager and Steve McReynolds. So Richard is a manager with Ingevity Asphalt Technologies, where his focus is warm mix asphalt, asphalt mixture performance testing, and understanding the impacts of warm asphalt on EPDs and LCAs. He earned his VSCE from Texas A&M and his MBA from Midwestern State. He's been a member of AAPT since 1999 and has participated in ASTM since 2001. And already, Richard, I'm like throwing out a bunch of acronyms here, just in your bio. Richard worked in various roles at TxDOT, and then he moved to the private industry, working at Koch Materials and Sem Materials before Ingevity. Considered the asphalt technology expert, Steve McReynolds brings over 20 years of industry knowledge as the quality control manager for Duval Asphalt. As the District 5 Bituminous Coordinator and District 2 Bituminous Manager during his tenure with the Florida Department of Transportation, he is known for his consultative and technical advice, which provides strategic problem solving with a variety of solutions. Steve is a sought-after speaker across the industry and has presented at numerous events around the country. And I'll be your tour guide, I guess, addressing any questions at the conclusion of our trip. So Richard, I think we're ready to get started.
Well, thank you, and I appreciate everybody joining us today. We're going to talk a little bit about Evotherm warm mix sustainability and this trial that we did with warm mix at Duval Asphalt. The project trial was last May, and so we'll jump into it right here. So here's an outline of what we're going to talk about. We'll talk a little bit about what the road forward is with NAPA. I'm sure many of you, if you've know anything about what NAPA has been talking about recently, you've heard about this. We'll talk some about the environmental product declarations, the NAPA Eco-Label program, what it takes to create an EPD, what some of the impacts are on global warming potential, and then we'll look at the EPD that was generated for the mix that was used on this project. And then finally, we'll look a little bit at the fuel use and the fuel that was saved when you run a mix warm. Here are a few acronyms that you'll see as you get into the life cycle and EPD world, and you'll probably see these in this particular presentation. Many of you have probably heard about the Road Forward from NAPA, which is NAPA's vision for net zero and carbon emissions for the asphalt industry. Many agencies and governmental bodies are considering greenhouse gas emissions in their project funding and procurement decisions, and so the asphalt industry is leading the way in this area. NAPA has developed a set of long-term goals and tactics for achieving the net zero emissions by 2050. This plan was put together by a 21-member task force who met throughout the year during 2021. This is the genesis, or this presentation today is really kind of what got us into looking at the fuel use. One of the benefits of running warm mix is obviously dropping the temperatures and using less fuel. Most of that shows up in an EPD. This is the framework that is used to quantify greenhouse gas emissions, and EPDs is part of that. And the Emerald Eco Label tool is a part of this framework. And you'll notice that the EPDs that we're talking about today are considered cradle to gate, which means that they include the materials, the transport, and the production. This production phase is where the benefits of warm mix come into play. So to understand what carbon emissions are, it's helpful to understand what kind of carbon we're talking about. This graphic gives you an idea of which CO2 emissions we're discussing here today. Essentially, we're looking at embodied carbons. And let me get my pointer up here. These are the types this is the type of carbon we're talking about as embodied. And this comes from the manufacture, transport, and installation of materials like asphalt mix. It differs from operational carbon, which is this type, and which is typically generated from from buildings and then living in the built environment. And you may wonder, what is the built environment? Well, this gives you an illustration of what the built environment is. The built environment produces about 40% of the greenhouse gas emissions. And so this kind of gives you an idea of where how these emissions are divided. When you look at an EPD, and if you're not aware, this is what an EPD is, Environmental Product Declaration. It's essentially a nutrition label for various products. The Napa Eco Label tool generates EPDs for asphalt mixtures, and the EPD document is an 11-page report that's generated by this program. So EPDs are part of the corporate greenhouse gas reporting framework. And as you'll see here, they're part of the scope 3 or indirect type of emissions. So they're part of there's indirect emissions that are upstream and then also downstream of what is considered scope 1 direct emissions. To give you an idea of how asphalt mix and mix production impacts scope 3 emissions, this illustration will help. The Oregon Department of Transportation generated their greenhouse gas emissions inventory for 2016 to 2019 and reported that 70% of all the emissions were scope 3. Of the scope 3 emissions, 50% can be attributed to the asphalt. And this works out to about 57% of the embodied carbon emissions are related to asphalt and asphalt mix production. And so using warm mix can help in this, but in reducing your emissions. But the question is by how much? All this means is that our industry needs leaders like Duval Asphalt, who's willing to produce mixtures and decrease their greenhouse gas emissions through the use of warm mix technology and lower production temperatures. So now we're going to talk a little bit more about EPDs. These are some of the key components of NAPA's EPD program. You'll see here, these are the general program instructions. There's an underlying life cycle assessment that was done for the program. There's product category rules. And then finally, you have the EPD software. You can access all of this by going to asphaltepd.org. I'm sorry. Well, actually, that's where this program is, asphaltepd.org. So a little bit more about the Eco Label program. One of the things to keep in mind with this is that it generates EPDs that are plant specific and mix specific. Now, that's a little different than what some of the other types of products that are out there, such as concrete, where they have industry averages. The one nice thing about the Emerald Eco Label tool is that it's very specific to the plant where the material is produced, and it's very specific to the mix. So how do you use the Emerald Eco Label tool? You go to asphaltepd.org and you register. There's a couple of webinars you have to watch and then pass a couple of quizzes. Once you do that, then you can gain access to this tool. One of the tools that was developed was this spreadsheet that NAPA has out there that helps you gather all the data that you need before you start actually inputting any of the information. You have to go through the process of purchasing access for your plants. You enter this data in for your various plants and then upload some supporting documentation. What sort of data is required? Well, typically you're going to need 12 months worth of fuel use data, and they want that to be within the last 5 years. And it's for whatever type of fuel you're using at your plant. and it's going to include your burner, the hot oil eater, if you've got a generator of any type, and any sort of equipment at the facility, such as loaders, skid steers, those types of things. You'll need to know about the electricity consumption, any sort of water consumption, and then finally you'll need to know about the total mixed tons that are sold. And one thing that NAPA points out here is that although this data is confidential, you really can't see what is actually input in this. It doesn't show up on the EPD. We'll take a look at that a little bit later. For the mix design, you need to have all of the various materials identified, all the different aggregates, the asphalt binder, how much RAP or RAS you're using, or any of the additives. And then finally, you'll need to know how far you're transporting all of these materials and what type of transport. Is it truck, rail, or barge? And then finally, you'll need the mix production temperature. And to give you an idea of what an EPD does, or what the global warming potential is from a typical plant on a typical mix. Say you have 95% rock, 5% asphalt binder, you're transporting these materials about 22 miles. You're using natural gas, and you're burning about 289,000 BTUs per ton of mix. And you're using about 3.3 kilowatts per ton of mix on your electricity side. And this is what the total global warming potential would be for the mix. You'll notice that it's divided by the A1, A2, and A3 portions for the materials, and the transportation and the operation. You'll see that the most of this comes, in this particular example, comes from the material side. This can be very different depending on where you are in the country and what your particular situation is at your plant. So one question that we get a lot, and I'm sure that NAPA and you have seen this from what NAPA has produced, is that RAP can help you reduce your emissions. You can see here, as you begin to increase the amount of RAP, your global warming potential numbers start to decrease. Another thing that can happen in here, and another benefit you would get, is this: as you begin to drop temperatures when you're using warm mix, you can also see a decrease in your global warming potential. It's a little bit more difficult to do that right now with the way the Ecolabel tool is set up, and we'll talk a little bit more about that in just a minute. So this picture gives you an idea of how many plants have EPDs in the U.S. Or how many plants by state have EPDs. And so you can see that in Colorado, that particular state has the most plants that are producing EPDs. And the reason would be for that, I think, is that there's legislation in Colorado that require contractors to submit EPDs with their mixes for certain types of CDOT projects. This is the number of EPDs that are in each state. So you can see, again, there's over 70 EPDs for different types of mixes, or 70 different mixes that have been characterized using EPDs in Colorado. And you can see the various states around the country that are beginning to get more and more in here. Florida's beginning to get more, thanks to Molly. She's done a lot of EPDs for Duval. There's several contractors in Texas that are beginning to generate them, as well as in Oregon and several of these other states. So what are some common questions about EPDs? What's the biggest contributors to greenhouse gas emissions? Well, as we alluded to in that earlier slide, aggregate hauling really has a lot to do with that. If you're hauling by barge and your aggregates are coming from a long distance, that can have a big impact on your global warming potential. If you're hauling it a long way by truck, that can also have an impact. The type of burner fuel that you use, as well as how much you're using, can have an impact on what your global warming potential is. And then also how much asphalt binder you're using in the mix. That will definitely have an impact on what the GWP is. So another question is will these types of mixtures have an impact on quality and durability? Well, one thing to keep in mind is that these specifications are not going to go away. These requirements for environmental type of mixes are not going to go away. But some good news is that the balanced mix design process can help in this process. And I'll point out that recently NCAT has published a case study using warm mix, and it had a little bit of RAP in that mix as well. And this has been published recently on the NAPA website. This is the name of that particular case study. It's called Improving Cracking Resistance in Alabama. If you get this presentation after the fact, this is a link that will take you to that. If you go to the Balanced Mix Design resource page on the NAPA website, you can download a copy of this report. So does the EPD give credit for warm mix? Not yet. That's a kind of a complicated question at this point. Part of it has to do with the way they're accounting for the fuel use. And right now, the way the product categories are set up, that you don't actually get that reduction unless you have 12 months worth of fuel use data that you can input into the program at those lower production temperatures. Then you can get credit for it. And right now, there's not a lot of people in the US that have that much data at lower production temperatures. So can EPDs be used for pavement type selection? And the main question there is, can we compare concrete versus asphalt? Well, the short answer to that is no. You can't compare these two materials, and you can't compare their EPDs. And the main reason is because their product category rules are different. So all of the upstream data is different for concrete materials versus the asphalt. There are harmonization efforts underway. You've probably heard of some of the stuff that's going on with the environmental or the EPA, and there's a lot of effort in that's going to come out over the next year or two, where they're going to try to make some sort of harmonization between these types of materials, and they're looking to have agnostic product category rules for these different types of materials. So some key takeaways here. EPDs provide verified data for quantifying environmental impacts, and these buy clean policies are coming around the country very rapidly. The Inflation Reduction Act is going to increase the demand for these low carbon materials, and there's different types of existing practices and technologies that will help you reduce your emissions, with one of those being using warm mix technologies such as Evotherm. You can help create EPDs for your company. You can start with one plant, and then you can begin to expand to these EPD production for various plants. I've done these for one of the contractors in the state of Oklahoma, and essentially it takes, once you've got all the data gathered, it takes about an hour or two to generate all of these EPDs. So let's jump into the mix, the EPD for the mix that was used for this particular trial. You can see this is actually this is the cover sheet on this particular report. Molly put this together for Duval, and you can see here the mix name is in here. The entity for which the material is produced is Florida DOT. The specification, which is an SP 9.5. It's a dense super grade, 9.5 millimeter, using a 5828. And one thing I'll note here is that on this particular EPD, it says it was produced between 300 and 320 degrees Fahrenheit. In actuality, when we ran this trial, we ran at 325, 275, 265, and 250. So keep that in mind as we go through this. This notice statement is on every one of these EPDs. This tells you what the EPD declaration number is, and the software that was used to produce it, the date it was issued, those types of things. You also notice right here, there's a URL, and this is a permanent URL for this EPD. And it will, if you go to this particular EPD or this URL, you will find this EPD. It will be out there in perpetuity. So again, this particular mix was not actually produced at those particular temperatures, and this is the notice that shows up on this particular statement. I mentioned earlier, this is the detail that the EPD gives for the different types of material. So really all you know is that it tells you that it's natural stone. There was wrap that was used in this mix. And we'll point out here that we used percent by weight. It had almost 40% of, of wrap in this particular mix. And then the binder in here was around 4%. The rest of the material was a natural stone. This is the environmental impact summary table that's listed in the EPD, and it gives you the information on the global warming potential. And for this particular mix, it was around 72.7 kilograms of CO2 equivalent per ton of asphalt mixture. And in this case, this number is related to a metric ton. The number in parentheses is related to a short ton. It also gives you what the ozone depletion potential is, eutrophication, acidification, and the photo-ozone creation potential for each of these mixes. The declared unit on an EPD is 1 metric ton or 1 short ton of mixture of asphalt. That's important to know as we move forward. The declared unit is something that's important to remember. This chart is the life cycle impact indicators, and this goes through and breaks down essentially those 4 or 5 areas that I talked about on the previous slide, but it breaks it down into the A1, A2, and A3 segments. So these EPDs are what are known as cradle to gate, so they go to the gate of the asphalt plant. And so this is the amount of carbon that's emitted per ton of mix to get it out of the gate of this particular plant. So one of the things that's very useful in the Eco Label program is a tool that's called the optimizer. And one of the things that you can do in this optimizer is generate these diagrams, and they're called Sankey diagrams. And you can look at different variations of what happens with a particular mix. And in this case, when Molly put these together, I asked her to generate a variant for the plant where we dropped the fuel use as we begin to drop the temperature. Through the work that we've done at Ingevity and measuring fuel use while we're running warm mix, we've got a model that can essentially tell you about how much, what the percent drop is in fuel use by temperature. So in this case, we did that here. And on this mix, you can see that we were running at 325. The CO2 equivalent, or the carbon equivalent here, the global warming potential, is 65.9. As we begin to drop the temperature down to 275, we went into the program and adjusted the fuel use. And you can see here, let me back up one. Here, the burner was around 20.2 kilograms, and this is the amount of CO2 that's related to burning that much fuel for this particular mix. When you drop it, the temperatures, you use less fuel, and it shows up here where you have about 16.6 kilograms of CO2 produced when you're making it at 275. When you drop it down to 265, it's around 15.9 kilograms. And then when you get to 250, it's around 14.9 kilograms. So to summarize that, you can see here that as you begin to drop the temperatures on this particular mix, the global warming potential number begins to drop. Again, also you'll see that the contribution from the natural gas, it also, the contribution to the global warming potential from the natural gas, when you burn it, it begins to drop here as well. So my colleagues at Ingevity, we spent a lot of time collecting this data, and my colleague Trey Wersh put this slide together, and we used a natural gas price of $9 per MMBTU for this particular scenario. And you can see here that at this particular plant, we were running about 200 tons per hour, and this is the type of plant. We had 40% wrap, and we assumed that they run about 150,000 tons of mix per year. And if we ran it at these lower temperatures every year, they could save about $60,000 a year just by running the mix at 265 degrees Fahrenheit, or about 41 cents a ton. So that's one way that the warm mix can help reduce your costs when it comes to running the fuel costs essentially. And this is one of the benefits from using a warm mix technology. And it also helps out from an environmental standpoint. This is another chart that we've developed based off of a lot of the work that we've done here. And it shows essentially, as you begin to drop the temperature, you begin to save money through the production of using less burner fuel. So with that, that's the end of my portion of it here, and I'll turn it over to Steve.
Thanks. So as Molly mentioned at the start, that a lot of studies have been done on the effects of the binder, mix performance, and pavement design with warm mix. We kind of looked at it here at Duval Asphalt that we use in Ingevity product Evotherm day in and day out. We use high wrap 40% day in and day out. So let's lower these temperatures and see what we can find out and see if this is really going to be realized and primarily in the fuel savings as well as the performance in the field of the mix. And along the way, we gathered some pretty interesting data. Again, overviewing, we did initial stack testing to get a baseline of your carbon monoxide, nitrogen oxide, volatile organic compounds, and carbon dioxide. Concentration was on the CO2 because I was told it's the bulk of the pollutants. So it's the largest piece of the pie against the COs, the NOx, and the VOCs. And then we produced this mix over 3 days. So 3 consecutive days because we wanted to run at each temperature a minimum of 1 hour steady. Like I said, it's a 40% wrap mix, 200 tons per hour. It's an SP95, as Richard had mentioned, utilizing PG 52-28. And there again, the 4 temperatures. The 3 main focuses, again, the green initiatives, the visible emissions tracking at the plant and also at the paver, the financial savings relative to temperature reduction. So if we lower these temperatures, how much are we really going to realize in our savings, especially in the fuel? And then also field effects, like I mentioned, impact on compaction efforts and workability. Richard had mentioned some of this. According to the greenhouse gas emissions inventory for asphalt mix production in the United States, current industry practices and opportunities to reduce future emissions. One way to reduce these emissions at the plant is to implement or increase the use of warm mix technologies. So let's get into some of the emissions here. And these are the stack emissions that we measured during the production. Again, the baseline 0, so anything above was the 325. And then the drops are below it. And you can see the color coordination of 275, 265, and 250. Again, CO2 is the bulk of the pollutants. So those numbers are the most impactful. Also, we looked at fine particles and very fine particles, mostly with the fine particles are the stuff that you can see, like smoke, sand, carpet fibers, those things you can see versus the very fine particles. So in order to do this, they put particulate emission devices. They installed them at the plant. They put them underneath the silos. We utilized 2 silos, I think, for this. We did drape the silos with tarps on the outside to kind of keep the wind away because we were, I think, in late spring, early summer. So we do have some wind. We're relatively close to the Atlantic Ocean here. So wanted to keep that down. As you can see here on the left-hand side, that picture is the smoke, or what you can see at 325 degrees. This is during loadout or opening of the silo and loading the truck. Then on the right-hand side is 275 degrees. So you can visibly see that the smoke is reduced significantly, almost to nothing there, just by lowering it from 325 to 275. These were also located on top of the silos, and you can see, again, the top of the silo, the smoke on the left is 325 degrees, and on the right is 275. Not quite going on top of the silo. You do get a lot more smoke up at the top of the silos. So it's not quite gone, but it is significantly reduced to the eye. Here it is kind of in a graph. These are the comparison of hot mix and warm mix particulate matter. This is, like I said, it's for a continuous reading for an hour at each temperature from the top of the silo. So we've all seen smoke on our jobs. This kind of quantifies what we see. So the red graph is your 325. So that's all the smoke you're seeing. And you can see that it almost baseline at 275 degrees. So we really reduce that particulate matter by going to 275. And then you can see it continue at 265 and 250. We also put these particulate matter sensors or devices on the back behind the screed of the paver, over the auger box, and then behind the hopper. Again, we want to look at it at the plant and also where our crews are working every day. So here's a at the paver, again, almost baselined at 275 degrees. So a big drop. And then again, you can see at 325, you're really seeing the particulate matter in the graph. Again, readings for an hour at each temperature. This is at the paver behind the screed, I think. Yeah, behind the screed. So this is data from all the devices. So the auger box, the hopper, the screed, silo 1, silo 2, and the top of the silo. This kind of quantifies the smoke that we see on the jobs. You can see the different temperatures quantifying, what the particulate matter measured at those different temperatures. This table shows the total percent reduction in particulates emitted over 3 days of production at each different area. So the auger box again, the screed, silo 1, silo 2, and the top of the silo. So you can see the reduction at each place over the temperatures over those 3 days. So this is a cumulative over the 3 days. So there's quite a bit of reduction, as you can tell. So next, I guess the important part of your contractor is this energy cost mix per ton, and this is in Florida. So how does this translate to dollars? These numbers were calculated, as Richard mentioned, using $9 per million BTUs. So lowering the temperature shows savings at different temperatures run for 40% wrap, again, at 200 tons per hour using the Aztec double drum. And here we're assuming that we're doing 150,000 mixed tons per year, and annual savings are tens of thousands of dollars per plant. And we'll throw those up there. So here's kind of the reduction. Again, it's 275 degrees. You're realizing a $54,000 annual savings based on this. Then so on and so forth to 265 and 250, where it's almost 62 and almost $77,000 a year in annual savings. That's pretty significant. This is a duplicate slide. The next two actually are what Richard had shown. I think my thoughts on showing this is that you're showing these reductions in savings in the fuel consumption over two different types of plants. So we have a GenCore and two Aztecs, but yet we're running different tons per hour rates. So out in Utah, they're running 360. We were running 200, and over in Virginia, 290 tons. And then also at different wrap contents, 15% wrap, 40% wrap, and which we ran, and then 30% wrap. So you can see there that the significant savings running at the different temperatures at the bottom, 260 for Utah, 265 for us, and then 260 over in Virginia as well. And again, this is another duplicate slide of Richard's, different color. And I think it's a little bit different because we're showing the money going up the left and the temperature's going to the right. But regardless, it's showing 9 to 10 cents per ton for every 10-degree drop in temperature. Now it goes all the way out to 200. I don't know, we'll go to 200, but it kind of extrapolates it out as you lower the temperature as it goes. So a little bit on the field effects, because everybody's always worried about that. We paved a very large parking lot for very large delivery service. I think there's sales too. There's not public sales, but there's a lot of delivery trucks, a very large project. So there's a lot of handwork, as you're well aware in a parking lot situation. You're going to have drainage basins in the middle. You're going to have landscape curbing that comes out. So there's a lot of handwork, which we were really interested in. Hey, how is this going to affect the crew when it comes to handwork? It's one of the hardest parts of paving. So, you know, dropping these temperatures, is it going to affect the workability of the mix? So I can tell you, we talked to the crew and there was no effect of workability. Using the Evotherm and the lower temperatures, the mix was just as workable at 325 as it was, or at 250 as it was at 325. Another part of the field effects is density. Of course, we're all concerned about that. So we didn't cut any cores in this parking lot, but what we did is we used a pavement quality indicator, which we use day in and day out. Most of us in our asphalt paving business, we use it as a process control or quality control tool to see if we're achieving density at a particular rolling pattern. So we did PQI's version, or their directions, where you take 5 readings at one spot and then average and get a density reading. Like I say, we didn't cut cores, so these are not correlated to cores. But if you've been involved in QC or process of asphalt, you'll know that you're looking for consistent numbers, and then you know you're achieving what you want to achieve. And you can see at different temperatures, at 325, 275, and at 250, these numbers were very comparable and very consistent within all of this. So that, as a quality control guy, speaks a lot to me. The handwork, can I make it look good and sell it to my customer, as well as I know that I'm achieving density. And then going back to answering to management, yeah, we had a big fuel savings. And like I said at the start, this is from using what we use every day, 40% wrap, Ingevity's Evotherm product, and now we've lowered the temperature, so now we're realizing a fuel savings. We also have plenty of data that we can show here. Molly has it at ATS if you want to contact us, to where the mix was tested inside the lab, and I think Ingevity has some of that as well. So Molly, I think I went through that fast enough to save us a little bit of time. Let me try to unshare my screen here.
Yeah, thank you. We have about 5 minutes, so we can address some questions that we got during your presentations. Thanks, Steve. Thanks, Richard. Our first question here is, do you have data and installations in Florida and conditions / life of warm mix versus hot mix pavement? And I think Richard's going to answer this one for us.
Yes, we do have data. We actually collected mix from this particular project, and we characterized it using dynamic modulus and cyclic fatigue. And we did we ran that through the FlexPave pavement design software, so we could project that. We don't have that data here today, but yes, that data does exist. I would also point you to NCHRP report 779, which was done about 10 years ago, where they used warm mix in a lot of different locations, and it showed that actually, if you the life expectancy of a warm mix project, especially the Evotherm type of warm mix additives, actually you can extend the service life of the pavement by anywhere from 10 to 30%, depending on the production temperature.
Okay, great. Thank you. We have another question. Have EPDs for warm mix additives been published to indicate the environmental impacts of their production and use in warm mix asphalt? Rich, I think you can speak to Ingevity.
Yeah, yes, EPDs for Evotherm have been published. You can go to Ingevity.com, they're the public website under sustainability, and you can see the EPDs that are out there. I think currently there's only The only Evotherm M1 is out there, and Evotherm P25 is currently out there. We have more that are going to be published probably within the next, probably the next month or so. They're completed. We just haven't got them finalized and put them up on the website yet.
Okay. What was the additive cost per ton? Can we talk about that?
I'm not sure what the cost per ton. I'm a quality control manager. I'm not the CFO. So
I don't know exactly what it cost, Molly. I think it was like $1 or so, somewhere in that range
Per ton.
per
Okay.
ton.
All right. So this presentation outlines benefits of warm mix from a couple different perspectives. We talked about the health and safety of our workers, financial impacts, and then even the lack of impact on workability. So what do you say to your FOB customers who insist that the mix they purchase is piping hot, Steve?
well, I think it's an educational thing that we have to really work closely with our FOB customers and let them know that we've researched this product, that it works. And this is the future. I mean, this is the way we're going, the way the fuel costs are today, that, we need to save the cost so we can pass that on to our FOB customers, and then as well as their customers in return. So it's an educational process. It's just like when we switched from Marshall mix here in Florida to Super Pave, it was all educational. Everybody wanted that, the S1 or the S2, and we have Super Pave, and we got past that, and I think we'll get past that as well here in changing from hot mix to warm mix.
Okay. Do you know what percent of Florida asphalt producers are using warm mix?
Not right off the top of my head, but if you go to the Florida Department of Transportation State Materials Office website, they have that data available.
Okay, great. I think that information, and then Richard, when you reference the NCHRP project earlier too, we'll make sure to have links to these answers for everybody when we publish the presentations and the link to the recording, so you can go back and review that. Okay, we have just one more minute. So, Richard, while EPDs do not currently give credit for warm mix, producers can select warm mix and lower temperatures when entering their EPD data in the Ecolabel software. So what effects do those variables have on the EPD?
Right now, those impacts are relatively small. They won't necessarily show up unless you actually put in a reduced fuel amount. So when you use the warm mix additive, your EPD global warming potential will go up slightly. Again, it depends on where you're producing, how far the material is being transported, those types of things. And when I say slightly, it's like less than a kilogram of CO2 per ton. So it's a very, very small amount considering the overall potential. And one thing you have to remember is that when these EPDs are only good to the gate of the plant, they don't include the use phase of the material or the maintenance and all the other stuff that goes on after that. So there's more to this story, is what I'll say.
Oh yeah, we're like just in chapter 1. So anyway, thank you both for your time today. We're going to wrap it up. A recording of this presentation will be available. The link will automatically be sent to you probably tomorrow. In addition, we will have these presentations available to you on our website, and that link will be included in the email that's sent. So thank you all again for joining us today. Steve and Richard, thank you very much for your time.
Thank you, Mom.
It's a great presentation, and we'll see you all again on our next road trip.
All right,
Bye.
Thanks, Molly.
Bye now.